Hey, this video will look at domain and range of functions. So understanding what domain is, domain are your possible values for x. Range are your possible values for y. So we want to get used to some notational issues such as using interval notation versus inequality notation, and knowing how to build maybe sketch a function given domain and range. So first type of problem you will see is basically able to identify the domain and range from a graph. So looking at this one, we can kind of get an idea of what's going on. So I can see my x's are going to be going from -5, and they're going to be stopping out at 6. So that's the first thing I kind of observe. And the y values are bottoming out at this point and topping out at this point. So one technique that's really nice to look at is to imagine putting a rectangle around the whole figure. Okay, this is what I'm going to be looking at working with. So I want my rectangle to go between these values. So domain is what x is. So my x is going to start at -5. I've got a solid dot at that point, and it's going to go out to 6. So my domain is -5. When you have a solid dot, you have equals. I go from -5 to 6. I have an open dot at 6, so I don't have equals. And I always use less than signs if I go from lower to higher. So -5 is less than or equal to x, which is less than 6. Now, you could also do this in interval notation. Interval notation, we're going to go from -5 to 6. Close bracket when you have equals, that's a solid dot. Open bracket when you don't have equals. And that's the interval notation. So you need to be able to work with either one. Usually when you're going to go over and have to describe the domain and range, you can use either one, but you have to be comfortable to be able to work with either one. Okay, my range. Now range sometimes is a little harder. You can look at the y values. My lowest point is -3. My highest point is 5. The graph goes down and touches right here. Now you got to watch out because we're going to see an example where we may have an asymptote where it doesn't touch it. And this is where you have to interpret it. If I see a graph coming down there, I'm going to assume that it actually goes down and touch, doesn't just barely miss it, because it has a definite bottom point. So that's what you got to look for. So my lowest y value is going to be -3. My highest y value is +5. They both worked with equals. The fact that we have an open dot over here is not going to change the range. It basically got filled in this process. Interval notation, they both have equals, so I use closed brackets on both. So now we're going to look at the second graph, and this one has an asymptote. So the range is going to vary a little bit. So we see this asymptote that's going across on the bottom right here. So I'm going to kind of try to put a rectangle around it, but my rectangle, in essence, is really going to be open-ended at this other end because it keeps going. So that tells me, since my rectangle keeps going, I get all values of x that are going to be less than 4. So I could even use the interval notation kind of idea of going from -infinity up to 4 with an open circle. Now I never can equal infinity, so I use an open bracket. Now I could translate this directly into inequality notation. -infinity less than x less than 4, or I could simply say x is less than 4, and that would have been okay. My range is going from -4 up to +4, but because we have this asymptote, the graph never actually hits that point. It just continues on forever. Since it continues on forever right here and doesn't really ever cross this line, well, that's going to be my asymptote. And since I never cross over that -4, it's going to have an open circle. It's equivalent to like having an open circle. It's not going to be included. So I'm going to go from -4, but I do hit a peak at 4. That's going to be a closed bracket. Or in writing in inequality notation, is -4 is less than y, which is less than or equal to 4. Some students prefer the interval notation because it's a little bit quicker to write. The advantage of the inequality notation is I do know this is range because I have the y there. Okay, so now we're going to try to sketch it based on the domain. So this first one, I want to go from -4 to 5. So you could think of this as, okay, I've got a solid dot. I'm going to go out to an open dot, and I want to go everywhere in between. That's where my x's are going to go. For the y's, my lowest point is -6, which was open, up to 4, which is closed. I want everything in between. Now, in essence, we can build a rectangle around that. This is where I have to have my graph contained. It needs to go between these values. Well, notice how I have an open circle here and an open circle here. I'm just going to put an open circle down at the bottom. Closed circle, closed circle. And put closed circle at that other corner. Now, the quickest way to draw this would just be a line connecting the two. But as long as I draw anything that I don't go outside the box and I only move forward, any kind of a graph would be okay. As long as I have, in essence, like a starting point here and ending point down there. Now we're going to look at this other one where we have an open-ended x. So it's starting at -2. Basically, I have a solid dot, and it's going to go off forever. And it's going on forever over here. The y's, well, I'm going to be going down to -3. And then I'm going up to, but I don't want to go all the way up to 6. So I could have like an open circle. But what's likely happen, I know I can't cross over that. So I'm actually just going to draw a line to say I can't cross over that. Because this is a case where we could easily do an asymptote. Now there's ways around this. I mean, you could possibly do something, but it doesn't work as well because you get running into domain issues. So I do have two solids though, so I'm going to put a solid dot over here. And I want to draw a graph that goes up to but doesn't cross over this one. So I'm just going to draw a curve that heads towards like an asymptote. So that gives you a little different version of doing a little problem with domain and range.